Okay, thank you all for coming. This is going to be a talk on web performance optimization, and I'll give some practical steps for reducing costs and improving the user experience. I believe it is the talk with the longest title at last, so I'm really hoping they have a prize for that. My name is Tom Partington. I'm a systems performance engineer at Civo. My Twitter handle is Parmigiana. That's our website. Throughout the talk, there'll be little short links that appear in that same spot. If you want to follow along and look at the research behind some of the things that I'm presenting, I'd encourage you to do that. So the first half of the talk is going to be about psychology, and it's going to be about why performance matters and why you should care about it. I'll touch on the benefits of optimization, the other things that it will give you that are good, and I'm also going to talk about why we get it so wrong, why so many sites out there are really, really slow. The second half is going to be more practical. I'm going to talk about what to optimize, and we're going to look at some of the common web performance optimization tools. And at the end, we'll have a little bit of a demo, and we'll look at a couple of websites that I've thrown together and the different effects of some performance optimization techniques. So I'm actually going to start this presentation with a story about a pizza. I was home a couple of years ago now, and I was really hungry. And I got a pizza out of the freezer, and I put it into the oven. And as I was walking out of the room, I pulled out my phone so that I could set a timer. For some reason, instead of going to the timer app, I went to Facebook, and I got completely sucked in. I was scrolling through my feed, and I forgot about the pizza. And the results were pretty horrific. I had to actually cook another dinner. I started wondering why this happened. Why could I totally forget that I had something in the oven? So I did some research, and you might have seen this popping up on news websites fairly recently. The way that Facebook affects our brain is actually similar to the way that gambling or drugs affect our brain. That link is to an article by The Telegraph, which is linking Facebook and cocaine. Facebook spend a lot of time and a lot of effort creating this link. This is something that they really want. For them, they want us to get sucked in and hopefully not burn our food, but they really want to create that engaging experience. And one of the ways they do this is that they test every single release of their application. This is a photo of one of Facebook's data centers. Inside these racks aren't servers, but mobile phones. And they do this so that they can test the performance of every single release to make sure there's no performance regressions, so that they can keep that engaging experience. They clearly care a lot about this. That's great for them. Why should you care? Turns out there's 3 important time limits when it comes to computing. And these numbers are from a study by Nielsen, the analytics and marketing firm, that was performed in 1993. So basically when the web was starting out. They haven't changed since then. They're still totally relevant. And in fact, it goes back even further than that to a study from 1968, which found the very same time limits for most human-machine interactions. So what are these time limits? Well, the first is 0.1 second, and that is the time for us to interact with a system and for it to feel immediate. That's where we feel that we're directly interacting with this object. The second time limit is 1 second. This is where we recognize that we're ordering the computer to do something, but that it's responsive enough that we maintain that sense of flow. And the really important limit here is 10 seconds, because that's the limit of most people's attention span when they're interacting with something like a website. As Tammy Everts puts it, it's not about neuroscience. No, it is about neuroscience, not entitlement. We don't want pages to be fast because we're impatient. We need them to be fast because that's how our brains work. In her recent keynote at Velocity, she gave some stats and figures about how people expect web pages to load in 2 seconds. And the one which I found more interesting was that people believe that over the course of a year, they spend 2 full days waiting for slow websites. That's probably not true, but that's people's perceptions, and that's how forward in our minds slow performance is. Google recognized this. They have a time limit for their websites that they set internally of 100 milliseconds, which is that 0.1 second limit I had on one of the previous slides. And the reason why they do this and why they set the bar so incredibly high is because they want using their sites and their applications to be the same as using or interacting with something physical, like a book. Facebook also obviously care about this a lot. They've recently launched Facebook Instant, which is a way for you to host your content on their servers, because they see that this gives you a whole lot of benefits. They want you to stay in that state of flow because they recognize if you go to a website that's slow, that's going to break that flow, cause you to leave Facebook, leave the application, and they don't want that. So why should you care about this? If you're not competing with Facebook or Google, why does this matter so much to you? And it's because in today's world, even if you aren't competing for the same products as Google or Facebook, you're still competing for people's attention. They don't have to be going to your site or to your product. They could be doing something else. Recently, the term the attention economy has been thrown around, and that's because attention is now our most limited resource. Faster websites are more popular. And it's no surprise when you think of the dominance of a global player like Amazon, who really cares about performance. But it does beg a question. Are websites faster because they're popular, because they have more revenue and they can invest more in performance and things like that? Or are they more popular because they're faster? Turns out the answer is actually both, which seems a little contradictory, but the fact is that the more popular a website is, the faster it gets, because people recognize how much of an impact that has, and they recognize that putting in that investment into performance really does pay off. There was a great analysis of the HTTP archive, the top 10,000 websites, where a user went through and looked at where popular websites placed in terms of performance and compared to less popular websites and how they performed. And across the board at every level, faster websites were orders of magnitude faster, or popular websites were orders of magnitude faster than slower websites. So what, you might say? I'm not selling anything and I'm not getting revenue from ads on my website. In fact, you might not even have an external website. Why does this matter to you? Because internal websites still need to maintain that sense of flow. You're going to keep people's attention while they're using your internal applications. You're going to reduce errors and distractions, and this is going to improve productivity, which is going to result in cost savings for your business. Everyone knows how frustrating slow tools are to use, and so by making our internal things fast as well, we're going to increase employee engagement and happiness. And interestingly, because these external websites like Facebook and Amazon and Google have pushed this so far, they've set the bar really high, and this has changed how people expect our internal applications to work as well. A study by CA Technologies in 2010 used EEG headsets to measure how, or the brain activity of people as they used a website. And they found that when a website had been throttled, and this wasn't a big difference, it was throttled to about half the speed, that it took people about 50% more concentration to complete a task. And a more recent study by Ericsson, which I'm blown away by this one, they found that the level of stress caused when you have to wait for a movie or a video clip on YouTube to buffer was comparable to watching a horror movie. So I don't know what that does if you're watching a horror movie on YouTube and it has to buffer. So that's some of the psychology. What are the other benefits of optimization? So I'm not going to talk about increased retention, increased conversions, increased time on site, increased user satisfaction, increased page views, or decreased bounce rate, because you can find all of that, hundreds of case studies, on a really cool website called WPOstats.com. This one's actually, I will tell a story about bounce and conversions. I was on the train recently, and the person next to me was using an app that I'm quite familiar with, and they were scrolling through, and they were waiting for the images of these listings to load, and the images weren't coming up. And I watched as they closed their app and opened up their competitor's M-site, and that worked. So that really brought it home to me just how much this matters. You can read all of the case studies you want, but when you see it in person, it's totally a thing. Optimized websites are going to be cheaper to run. You're going to need less servers, and you're going to need less bandwidth to serve your content. This is really good because it's going to reduce your AWS bill, and I'm sure pretty much every company wants to do that. Another story here is I spent some time on a website I was working at optimizing the fav icon, which is the really small little icon that goes in the top of a tab, and it shows you, basically lets you see which website you're on for which tab. These are really tiny images, and I shaved a couple of kilobytes off. I then went back about a month later and looked at the stats and found that over the course of a single week, that optimization was saving 50 gigabytes of traffic, which I found pretty significant. This is important because it's also going to save your users money. 1 in 5 smartphone users in Australia regularly goes over their data limit. There's a really cool site, whatdoesmysitecost.com, which you can put in your URL, and it will show you the cost of your website on different plans, postpaid and prepaid, around the world, which is really critical if you're targeting an emerging or an international market. Turns out Canada has super expensive mobile internet. Optimized websites are going to use less battery. This is because you're going to need to transfer less data, which is going to use the radio in your phone less. Smaller images and less JavaScript is going to use the CPU less. This isn't something that people are going to see directly, but it is important because it's going to cause all of the ICT infrastructure to use less power. When I was doing the research for this slide, I found out that data centers currently have the same carbon footprint as the airline industry, which to me was kind of shocking. But the really scary thing is that over the course of the next 10 years, that energy consumption is set to triple. Optimized websites can serve more users. One website I was working on, it was quite a few years ago now, had an event where an unexpectedly large number of visitors came to the site. And this was a problem because the application was making several database calls each time you loaded it, and that database hadn't been set up properly, so the app or the database had to do a full table scan each time. Apache was set up with its default configuration, or the web server was set up with its default config, and that web server was proxying to all of the rest of this organization's infrastructure. So when an unexpectedly large number of users came and they hit this website, which the developers had gone, yeah, it's a little slow, but that's not really a problem. It's a complicated app, that's fine. It took down the whole website. And this was critical because this is the one time when this organization was getting exposure, the one time when people needed this information, the one time this website really had to be up. We made some simple fixes to this. We updated the application so it only hit the database once. We added an index to the database so that it didn't have to do a full table scan. We added a caching layer so that half the time, unless you were requesting new content, you didn't even need to hit the application or the database. And we tuned Apache so that it didn't run out of connections quite so quickly. We then did some load testing on this, and we even got a third-party company to come in and load test it. And in that load testing, they couldn't bring the site down. Although I do have to put a little asterisk next to that, because this was the same company that tested the census website. Optimized websites are going to be more secure as well. For the same reason that you can serve more users, you're going to be more resilient to distributed denial of service attacks. If someone is maliciously trying to take down your site, if you can get all of your content onto a content delivery network, chances are that the attacker isn't going to be able to take down that content delivery network. Optimized sites are generally going to have less random third-party bits of JavaScript executing on their site, and that's a massive decrease in the attack vector for your site, which is important because your site is your brand and your reputation, and you really want to protect that as much as you can. Optimized sites are going to have better SEO. Google make no secret of this. The #1 factor in people remembering a website from a search results page is where it ranks, and the faster your site is, the higher it's going to rank. SEO is expensive. This is a really quick way to increase it. Optimized sites are generally going to be more accessible as well. There is quite a large overlap between accessibility and performance. When a web page is loading, it's building up a document object model, and at the same time, the browser is building up what's known as an accessibility tree. Anything which is going to cause your page to repaint or reflow is going to affect that accessibility tree, and this is really problematic for users who are using screen readers or interacting directly with a keyboard. Excess reliance on JavaScript is going to hurt performance, and it also means that you could be doing really bad things in terms of usability and navigation, so we want to avoid that. Custom fonts can be bad for performance, and they can be bad for accessibility. A lot of the time, if you're relying on a font and it's not there, that can cause your page to, in some browsers, to not display any text for up to 60 seconds, which is an awful experience. A lot of people actually swap out the fonts in their browser as well for accessibility. Comic Sans is very readable for people with dyslexia because no two characters look the same. So B's and D's aren't just mirror images. So you want to follow these best practices and not use custom fonts because chances are some people aren't going to use them anyway. Isn't technology going to save us? My phone is way faster than it used to be. My internet plan is way faster than it used to be. Moore's law is going to fix everything. Performance isn't really something we need to worry about, right? Well, it turns out there's a counter law to Moore's law called Wirth's law, which is saying that software is getting slower more rapidly than hardware is getting faster. And if you think back to like old websites, even though we were on such terrible connections, they still loaded faster than some websites do today. And the performance inequality gap is growing. Ilya Grigorik is a performance advocate at Google, and he gives a really great talk on resilience and explains in it that even though devices are getting faster, they're also getting cheaper. And the cheaper devices aren't getting faster at the same rate as the faster devices, so that gap is widening. The other thing to keep in mind is that even though you have a brand new fast device, it's not always going to be using its full power because it could be running hot, it could be running low on battery, there could be any number of reasons why that fast device you have isn't operating at full speed. Latency hurts performance more than bandwidth. If the internet was a series of tubes, then latency would be the length of the tubes, the bandwidth would be the width of the tubes. So latency is actually the deciding factor in how fast we can send data. Typically, if you increase the bandwidth by a factor of 1,000, the time it takes to load a web page only doubles. So the only way we can improve the latency because the limiting factor is the speed of light, is to move content closer to the users. And this is the whole reason why content delivery networks exist. This is also even more critical as mobile starts to increasingly overtake desktop as the method of consumption for most interactions. Downtime is actually less bad for your brand and your reputation than slow performance. Visitors are more likely to permanently abandon a slow website than one that's down. How do I know? There's a really great study from Soster on this. And the reason is that when you have a slow website, you're annoying your users. It's not a pleasant experience. They're only going to go to your site if they really have to. If you have downtime, turns out that people are actually kind of forgiving of that. And this is some more stats on this, where people looked at the conversions of a site that experienced some downtime. So the downtime is in the little dip there. And then after they came back, the number of conversions they had actually went up higher than it was before the downtime. And this is because people have things checked out or they're waiting to buy something and they're waiting for that site to come back so they can continue using it. It's really hard to earn loyalty and trust from users. And they're okay with you being down for a little bit. Obviously, you can't be down all the time. But if you're slow, you're really going to quickly erode that trust. Ilya Grigorik again gave a talk where he went through the 3 phases of performance maturity. I'm bringing this up because I firmly believe that most places are stuck in the first phase, which is treating performance as a bug. You only notice it when it's not there. It's something that you need to jump on and fix rather than treating it as a feature where you're thinking about it at all times. It's something you do continuously, starting with design, into development, and into production. The third dot point there doesn't have quite the same ring to it as the others, but what this is saying is that if you build your website to be fast from the start, you can actually, and you build resilience in, you can actually compensate for external failures. If the network is slow or spotty, if you build for an offline first experience and use things like service workers, people might not even notice that there's a bad experience there. Why do we get it wrong? We focus on the wrong things. I think this is getting better. In the early days of web performance, the vast majority of our time was spent trying to get things fast on the server. This is because that's where we had the best tools. We could really easily see the server performance. Measuring real users was much harder. Turns out that 80 to 90% of the time it takes to load a website is on the client side rather than on the server. When we develop things, we generally do it under ideal conditions. So most developers have awesome laptops. Most offices have awesome connections. We tend not to develop on like a really old laptop on a really slow connection. Facebook is trying to fight this. They have a thing they call 2G Tuesdays, where every Tuesday their developers can opt in to actually slow their network connection speed down to 2G speeds. And they do this because they're really targeting that emerging market where the connections aren't as fast as they are in the rest of the world. Some of our tools are flawed. Chrome DevTools is great. Its network throttling feature happens at the application layer rather than at the network layer. So when you're testing it there, it's giving you some idea of a slowdown, but it's not going to be truly indicative of how that application is going to perform on a truly horrible network. We optimize for delivery and for development and not for production. What do I mean by this? We tend to overuse frameworks. We'll import all of jQuery to do one small thing. Worse still is we'll use multiple frameworks because that makes our lives easier as developers rather than building it for the end users. And the worst sin of all is we use multiple versions of the same framework. And I've seen all 3 of these things on real websites. The feature fallacy is one that I think a lot of product managers suffer from. And this is the idea that the next thing we build is going to be the one thing that really makes our users fall in love with our application. Like, this is it. After we release this thing, they're going to get it. They're going to adore this, and they're going to come to us in droves, and they're never going to leave. That's really, really rarely the case. The last one, performance, is because we focus on features rather than the user experience. The last one is performance is death by 1,000 cuts. There's very few optimizations we can do which have a massive impact. Often, as with the favicon example I gave, it's a case of shaving kilobytes off something, and we're like, what is the point? It's only a kilobyte. That all adds up. How do we get better? We need to think about performance early. We need to start thinking about it at the design phase. The designers should be thinking about how a page loads, not just what it looks like when it has loaded. They also need to be producing optimized assets. They're the ones creating these large images and sending them to us. We want them to be aware of the performance implications of that, because ultimately they care about user experience, and that's what we care about as well. We need to measure, and we need to measure first before we make any changes so that we know if we've made an improvement. I'll touch on this more in a little bit. The adage, you get what you measure, is really true, and that's why we need to link these measurements or web performance to business metrics. So we need to think what do we care about? Do we care about conversions or time on site or page views? And we need to look at this and see how it relates to performance, because chances are there's a positive correlation there. We need to optimize, obviously, and we need to repeat this. This is a never-ending process. It's much the same as painting a bridge. Once we get to one end, we need to go back to the start and start again. This could sound tedious. I find it really exciting because the space is always evolving. There's always new techniques. There's always new tools. There's always better ways to do things. So yeah, I like the fact that we get to spend a lot of time on this. So what should we measure? Real users, first of all. You absolutely have to know how your application performs in the real world. A lot of companies will see that it works fine from their office network. We need to see how it works for people out there. We want to measure synthetically as well. Like any good experiment, we want to control as many of the variables as we can. So synthetic measurement lets us do this. It also gives us a really deep dive into what's happening. We want to measure continuously. Ideally, you should be measuring the site or the speed of your performance, or the performance of your website on every build. Every time you push a commit to your staging environment, you should see what has that impacted and how has it impacted it. This will let you catch regressions really, really early. We want to measure what matters. There's a custom timing API which you can use to do this. Twitter famously do it. They measure the time that it takes for the first tweet to appear on their page, because that's what they care about. They don't care about or they care less about the time it took to initially start rendering, or when the total page had loaded and all of the content had come through. They care about that first tweet being visible. You want to measure your competitors as well. There are studies suggesting that in order for you to notice a performance difference, it needs to be at least 20%. So you should be seeing how fast your competitors are and taking 20% off that speed, and that's what you should be aiming for. That 20% can be good if you're only a little bit slower, but yeah, you definitely want to be faster. You want to measure the worst case as well, the 95th at a minimum or the 99th percentile, because keep in mind that the 95th percentile is 1 in 20 people, the 99th is 1 in 100, and when you're looking at page stats and you're seeing like thousands or hundreds of thousands of page hits, you can quickly see just how many users are getting that bad experience. There's a really great article which I should have linked to on here, I forgot to, on the mindfulness of a manual performance audit, which is a suggestion where you go through And actually, rather than relying on tools to do this for you, you go through and you spend the time to look at what's loading on your web page and then put it into an Excel spreadsheet and group things manually, because that's going to cause you to spend more time and to think, wow, like we have a lot of assets, or we have a lot of third parties stuff on our site, or we have a lot of images, which when you're adding it all up yourself is going to have more of an impact than when you just see that number given by an automatic tool. So how do we get better at this? We optimize. The two things that you can generally optimize are the content, and you can optimize the delivery. What should we optimize for the content? The images are generally the biggest win. Over half of the average web page's weight at the moment is taken up by images. There's a lot you can do to fix this. This is where you generally see your really big wins. There's some techniques we can use, like the picture element or source set, to make sure that we're sending the right size image to the right device. There's no point sending a huge image to a small mobile phone. There's also a really cool tool called DSIM, or I think that's what how it's pronounced, which lets you optimize an image to the point where the human eye can detect a difference. So straight away, you can cut the size of an image in half, do that in a lossy way, but so it's not actually visible to the human eye. I've shaved off heaps of weight of images doing this, and no one can tell the difference. Audio and video, do you really need it? Probably not. If you are putting it up there, make sure you're doing it in a way that's a progressive enhancement, so that if it doesn't load, your web page is still usable. JavaScript and CSS are another big win. You want to make sure you're sending only what's needed. The latest version of Chrome DevTools has a nifty tool which will show you the coverage of how much of your JavaScript or CSS that you're sending to your users is actually being used, and I can demo that at the end. There's also a website called YouMightNotNeedJQuery.com, which shows you how to do in vanilla or plain JavaScript what a lot of people tend to rely on jQuery for. Fonts. 68% of websites have custom fonts on them, and they have an average of 3 custom fonts as well, which seems like a lot to me, especially if you're importing a whole lot of fonts just to make one letter bold. And third-party content, there's a really obviously a sweet spot with the number of ads on your site. If you start putting on too many, you're going to start impacting that user experience and driving your users away. So if you have the right number of ads, which to me is always less, you're going to actually earn more from those ads because you'll get more page views and people will click on them more. Delivery optimizations. Gzip your stuff. This is a really old one. Only 60% of the compressible content on the internet is actually being compressed. This is just waste that's going out there, which makes me sad. These stats are all from HTTP archive, which I mentioned earlier. You want to set the cache headers. Only 50% of cacheable resources have headers set. The quickest request is one that doesn't need to be made. A really good one, which is as close as you can get to free performance, is enabling HTTP2. To do that, you'll need HTTPS. At the moment, about 46% of sites have HTTPS. Only 14% have HTTP2. So there's quite a large gap of sites that could, as close as you can get, to flick a switch and just make it faster, like that old turbo button. And you want to use a content delivery network. This is the only way you can try and change the speed of light, by reducing the distance that the content needs to go. As I said, this is the whole reason. Only 19% of sites use a content delivery network for their main HTML. Finally, if you can't make your site go faster, you can at least make it appear to be faster. And this is once again bringing the design back into it. It's going to keep your users more engaged. There are some cool tools that you can use to check your website's performance. Chrome DevTools, it's built into Chrome. You open it with like Control-Alt-I, I think. Web page test is a great resource where you can go and plug in your website and it's going to give you all the performance statistics. It's lets you test from around the world in different browsers and different devices, which is cool. And it's really easy to share and compare those results. We'll look at that very soon. SpeedCurve is a really lovely interface on top of web page test. I've put a star there because it's the only one on this list which is a paid-for service. It's very similar to what sitespeed.io gives you, except you're paying for SpeedCurve. With SiteSpeed, you have to configure it and set it up yourself. So really, it's where do you want to put your time and effort and money. PageSpeed Insights is another one we'll look at shortly. This is a one that you'll plug in, and it will just tell you basically you need to fix these things, and it will give you hints on how to fix them. So this is where we can demo some of that. So I built a website that's all about jellyfish. You can go there and learn all of this stuff about jellyfish. But what I'm going to show now is this comparison of, in web page test, of these two sites loading. So what we can see is that to start with, both sites have no content. And then as they load, the top one is the optimized version, the bottom one is the slower one. As we go through, it's still taking a while. That first one loads in, finishes loading in about 4.5 seconds, whereas the bottom one takes about 17 seconds to load. If we come back. So if we go to the bottom one in PageSpeed Insights, this is running a whole lot of tests on this slow website, and it's going to give us a whole lot of hints on what we can use to optimize it. So you can see it's a static website. It's hosted in an S3 bucket, and PageSpeed Insights is telling me here that the performance is really poor. And if we run that same test for the fast one, it still needs work. I ran out of time optimizing this site, but we can see that it's way better. It's getting a score of 71. So it's showing the possible things to fix. Here it's how I'm loading the CSS. There's the website. If we look at DevTools, which is, so this is the one that's built into Chrome. If we reload that. Here, as the website is loading, let's check in the coverage. We don't want that one. So as the website is loading, it's telling me all of the elements that are loading. It's showing me what initiated them, how long it took, and it's showing me a waterfall timeline. I'm pretty close to running out of time here, but we have a break. I'm happy to hang around and show people in depth these tools a little bit more. Or if you want to go to that bit.ly link, which is there, then you can play around with this yourself. And I'll update that with a few more resources as well. So that's pretty much the end. Thank you. If this is something you're interested in, these are a whole lot of resources which are really good. The two that I would point out specifically are designing for performance and high performance browser networking. They're both free online. You can buy a physical copy of the book if you want to. They're both really great resources. The top one is more of a general introduction. The bottom one, high performance browser networking, gets into the really delicious, nerdy details of how browsers work and how servers work. It's really cool. Some other resources there for you as well. That's it. Any questions? Cool. Thank you. I'll publish these and put them on the Trello board for people to find afterwards. If you want to check any of the figures that I put out there, they're all true to the best of my knowledge. Thanks.